Hello, how to solve this exponential problem? This is 5 power t plus 1 equals negative 15, solving for the value of t that satisfies this equation. So, let's start by using this identity. If you have a power n plus n, this equals a power n times a power n, meaning we are going to have 5 power t times 5 to the power of 1, and this equals negative 15. From here, I can divide this by 5 and divide this by 5. 5 eliminates 5. I have 5 to the power of t, and this equals negative 15 divided by 5. I have negative 3. Now, what I can do will be to express this as 5 power t equals this negative 3. I can express it as negative 1 times 3. Then we apply natural log. I have natural log of 5 to the power of t equals natural log of negative 1 times 3. Now, if you have natural log of a to the power of b, this equals b times natural log of a. And also, if you have natural log of a times b, this equals natural log a plus natural log b. So let's do that here. We simply apply this right here. So you have t times natural log 5 equals, we apply this identity here. We have natural log negative 1 plus natural log 3. Now we have negative 1 here. So I can express this negative 1 as we have e power I times pi plus 1. This equals 0, meaning that e power I times pi equals negative 1. Moving this over here. So let's apply that right here. We have t times ln 5. This is t ln 5 equals, this will be natural log of, instead of writing negative 1, I have e power I times pi, then plus natural log 3. So right here, we go back to the same identity. If you have natural log a power b, this equals b times natural log a, meaning that t times natural log 5 equals I times pi natural log e plus natural log 3. So from here, we have t times natural log 5 equals I times pi natural log of e cancel out. You have plus ln 3. We can decide to isolate t by dividing this by natural log 5. Also divide this by natural log 5. Natural log 5 eliminates natural log 5. I have t equals I times pi plus natural log 3 divided by natural log 5. I can divide each of these terms here by the common denominator. I have t equals I times pi divided by natural log 5 plus natural log 3 divided by natural log 5. Now, if you have natural log a divided by natural log b, this equals natural log a to the base of b. So from here, I'll have t equals I times pi divided by natural log 5 plus natural log 3 to the base of 5. So we leave it this way as our solution. Now let's solve this using another complex variable for negative 1. So we have 5 power t plus 1 equals negative 15. We go back to the same identity. A power n plus m equals a power n times a power m. Meaning that 5 power t times 5 to the power of 1 equals negative 15. I divide this by 5. I divide this by 5. This eliminates this. I have 5 to the power of t equals negative 15 divided by 5. We have negative 3. We apply natural log. I have natural log 5 to the power of t equals natural log negative 3. So from here, I can have natural log 5 to the power of t equals natural log. Instead of writing this, I have negative 1 times 3. So right now, let's recall, if you have square root of negative 1, you have complex number I, that is iota. Now, if you take the squares of both sides of this eliminates it, so you have negative 1 equals iota squared. That means this, we are going to have natural log 5 to the power of t equals, this will be natural log. Instead of writing negative 1, we have iota squared times 3. Now we also have, if you have natural log a power b, this equals b times natural log a. And also if you have natural log a times b, this equals natural log a plus natural log b. That means we apply this first identity here. We have t times natural log 5 equals, we apply this one here. We have natural log I squared plus natural log 3. So from here, I can have t times natural log 5 equals, for this, remember the same identity, natural log a power b equals b times natural log a. So this will be 2 times natural log I plus natural log 3. So what I can do will be to isolate t by dividing this by natural log 5. I also divide this by natural log 5. Natural log 5 eliminates natural log 5. As t equals 2 times natural log I plus natural log 3 divided by natural log 5. From here, we divide by the common denominator, so we have t equals 2 times natural log I divided by natural log 5 plus natural log 3 divided by natural log 5. Now recall this. If you have log a divided by log b, this equals log a to the base of b, meaning that natural log a divided by natural log b equals natural log a to the base of b. So that means we are going to have t equals, this is 2 times natural log I divided by natural log 5 plus natural log 3 to the base of 5. Let's leave it this way. Now, if you observe, here we have 2 times natural log I, and this equals to what we have here, which is I times pi. So If 2 times natural log pi equals I times pi, that means the both solutions are obviously the same. So guys, this is it. Any of the methods you can use, you're fine. Thank you and goodbye.